We are going to be talking about choosing a method. So over the last couple weeks, we've gone over 4 different ways of solving a system of equations. So the 4 different methods of solving a system of equations that we've talked about are, number 1, we talked about how to solve them by graphing. You would take the 2 equations, graph them, and then look for the point where they intersect, if they intersect at all. And then the point where they intersect is the solution to the 2 equations. We talked about solving a system of equations by using substitution. Substitution. I always misspell that word. Where you take one equation that's already solved and then substitute it into the other equation for whichever variable it's solved for. Or you look for a coefficient of 1, solve for that, and then substitute it into the other equation. Number 3, we talked about elimination, where the x's and the y's are already all lined up, and the x's, the y's, the equal signs, the constants are already lined up, and then you either add or subtract the 2 equations to make one of the variables fall out. And then this is kind of a subset of elimination. We talked just on Friday about elimination with multiplication. So elimination with, I'm just going to abbreviate it, multiplication because I'm running out of space. All right, so we've got these 4 different ways of solving equations here, or solving systems of equations here. Now, from now on, including when we take a test or a quiz on this kind of stuff, or assignments, you can choose whichever method you want to solve this system of equations. So if you really like graphing them, you can solve a system of equations by graphing. And there will be some situations where graphing, honestly, is the easiest way to solve them. If you want to use substitution, you can use substitution. If you want to use elimination, you can use elimination. If you want to use elimination with multiplication, you can do that. However, you can't always use substitution, because substitution won't be the easiest method always. Quiet, please. You won't always be able to use graphing. It won't always be the easiest method. So, for example here, as we went through these methods, I'm sure some of you guys liked some more than the others. How many of you guys, as we went through them, liked the graphing method? Raise your hand. How many of you liked graphing to find the solution? 1 person? That's about what I expected. How many of you liked using substitution? Raise your hand if you liked or didn't like, or if you liked using substitution. Nobody? Nobody liked using substitution? Okay. Are you guys just not going to admit to liking anything in a math class? Is that what I'm encountering right now? Okay. How many of you liked using elimination, where you add the 2 equations together or subtract the 2 equations? Okay. Wow. Okay, cool. And how many of you guys liked what we learned on Friday, elimination with multiplication? Okay, it was okay. It required too much work. Okay. All right. So let's take a look at an example of a system of equations here, and I'll talk about how you can decide which method to use on your own without me needing to tell you in the directions. So let's say that we have a system of equations that looks like 3x plus 2y is equal to negative 1. And then we'll do 6x plus y is equal to, so, negative 10. All right. So if you have to choose a method for this, so how to choose? Stop whispering, please. All right, so how to choose. Number 1, if you want to graph this, how you would graph it is you have to solve both equations for y. Destiny and Caden, focus. If you want to graph this, you'd have to solve both equations for y, which nobody liked doing when I made you do it on that one assignment. Like, nobody liked doing it. Everybody hated it. So you'd have to solve both equations for y. You'd have to minus 3x from both sides, divide everything by 2, and then you'd have the equation in slope-intercept form. Minus 6x from both sides, stop that. Graph the equation, and then look for where they intercept. So that's one way that you could do it, but I don't think anybody would want to do that willingly. Substitution, you'd look for which of these has a coefficient of 1. So you could do graphing if you wanted to. I don't think any of you would choose that willingly. I could be wrong. You could do substitution because you have an equation that has a coefficient of 1 here. And you could do that by minusing 6x from both sides and then taking what y is equal to and substituting it in for y in the other equation. You can't do plain elimination because none of the coefficients match up as they are right now. However, you could do elimination with multiplication, because you could choose one of these variables to cancel out, and then multiply the equations by whatever you need to make the variables or the coefficients match up, and then either adding or subtracting. So of the 4 different methods I've taught you, 3 of them could apply here, which means that if I gave you this exact problem on a test or a quiz, Emily might choose to do substitution. And if she went through and was really cautious, she'd get 1 answer. Janine might choose to do graphing. And if Janine went through and was really cautious, she would get the exact same answer Emily did. And if Tanner wanted to do elimination with multiplication, if he went through, he was really cautious, he'd get the same answer that both Emily and Janine got. So you could do this 3 different ways and get the exact same answer, so long as you're being cautious about your math. Okay? So there's no one right way to do this problem. There's 3 different ways I've taught you right now that you can do this, and you can choose one of those 3 different ways to do it. And it doesn't matter so long as you're being cautious. Does that make any sense? So Colton, I've got 3 different methods here that we can choose from.
Yeah.
Which method do you want to choose? So do you want to solve them both? Substitution?
Yeah.
Okay. So that means what we're going to do is we're going to look here for a coefficient of 1. So which of these variables has, okay, y right here does, right?
Yeah.
So that means we need to get this by itself. So how do we move 6x to the other side? So I'm going to minus 6x from both sides. So what is y equal to then, Colton?
1. Oh, y equals -6x minus 10.
Awesome. I'm then going to take what y is equal to and substitute it in for y in the other equation. And I'm going to rewrite that. So this is the last question for you, Colton, then I'll move on to somebody else. How would I rewrite that other equation? Colton?
3x plus 2 minus,
And then in parentheses,
minus 6x minus
close parentheses, and then what's it equal to?
-1.
Perfect. All right. So now, Colton's chosen to do substitution. He did the first 2 steps perfectly. He did it really well. He's been really cautious with his math so far. Doing a good job. Tanner, what would I need to do next? Distribute. So if I distribute this 2 to both things inside, tell me what the left-hand side should look like.
3x
3x.
plus
Okay, plus
-2,
negative 12x. Totally agree with you. Minus 20. And then equal to what on the right-hand side? Perfect. So now I need to combine like terms. So Tanner, you're still on deck. 3x plus negative 12x. How many x's is that?
3x plus
Negative 9x. So I've got negative 9x minus 20 is equal to negative 1. All right. Rainy, what do I need to do next? To both sides. So plus 20 plus 20. So I get negative 9x is equal to 19. And Mr. Taft made a mistake when he created these, but we're just going to roll with it. So it should be, we're going to pretend that that was 18 instead of 19 when Mr. Taft made these. Actually, no, we're going to pretend that was 21 because that's what it should have been, because Mr. Taft made a mistake when he made these problems. I'm sorry. That's what Mr. Taft gets for making these up off the top of his head. So, actually, no, sorry, again. Sorry. I'm an imperfect person. I make mistakes all the time. What did I do wrong? Everything? I did everything wrong? I haven't done a single thing right? Okay, well you get to be. So we'll just call this 18 and we'll roll with what it would be. So then x would be equal to what if I fudge the numbers and make that 18? Negative 2. All right. Mr. Taft is a disappointment, I'm sorry. So if I substitute negative 2 in for x up here in this equation right up here, where we already have y set aside. So y would be equal to negative 6 times negative 2 minus 10. All right, Destiny. What's negative 6 times negative 2? Positive 12 minus 10. And so, Destiny, what is y equal to? And then anybody, we have to write this as a coordinate. So what would the coordinate be? Negative 2, 2. Perfect.
2, 2.
So if you had chosen to do this any other way, negative 2, 2. Not 2, 2.
2, 2.
Negative 2, 2, different. So if we had chosen to do this any of the other ways, if we were cautious in our math, and if Mr. Taft had done it correctly from the beginning, we would get the same answer no matter which method we chose. Stop that. So choosing a method, like so long as you're cautious about your math, and so long as Mr. Taft does it correctly from the beginning, no matter which method you choose, you get the same answer no matter how you set it up. Okay? So from now on, assignments and tests and quizzes included, we're going to test on this in 2 weeks, and we're going to have a quiz on Thursday. The quiz will be included on the test and quarter, or on the quarter and semester grade. The test will not, because it's going to be in 2 weeks. You'll be able to choose whichever method you want to use, no matter what the instructions say. So if you have a system of equations, solve it however you want to. If it says graphing, you don't have to graph it. You can use elimination or substitution. If it says substitution, you can use elimination. Okay? So, there's that. Next, let's talk about an extra credit opportunity that we have for